Welcome to this first video in our video series about digital cameras. In this series, we will learn how to connect digital cameras to digital monitors, how to configure our devices, and how to power them. Today, we will start by talking about our MCDx7000A camera series. After this brief introduction, you will know which different versions of this camera are available, how to connect them to your computer or monitor, and which one is the most suited to your application. Let us start by understanding the naming scheme of our products. The MCDx in the camera's name stands for Motec Camera Digital, and then the X is a placeholder for the camera's physical interface. It can be a B, which stands for broader reach, an E, which stands for Ethernet, or even an L, which represents our LVDS GSML2 version of the camera. The 7 in the 7000 stands for the camera's device family, which is our compact streaming camera without AI or image processing features. All these 7000 models come with the same physical specification and very similar features. The last 3 digits in the number represent the viewing angle of the camera. Lastly, the A at the end of the name indicates the camera's hardware revision. So a MCDe7115A would be a digital Ethernet camera with a 115-degree viewing angle, while an MCDb7180A would stand for a broader reach camera with a viewing angle of 180 degrees. The entire device family features a 100 megabit per second interface based on MAC and IP protocols. This interface allows it to stream a full HD video with very low latency. The camera's glass-to-glass latency is usually between 80 and 100 milliseconds. I have mentioned before that there is a broader reach and an Ethernet version available of this camera. Ethernet is the same interface standard that is commonly used in homes and stationary applications. It, however, has found its way into some mobile applications as well. Broader reach, on the other hand, is an automotive Ethernet variant that has the advantage of being lighter and cheaper in comparison. Broader reach is also known as Single Pair Ethernet, or SPE, or as the Base 100 T1 standard. I will use the different names interchangeably moving forward, but will always refer to the same standard. Our Ethernet cameras feature a supported and tested cable length of up to 100 meters without a repeater or switch in between, while on the other hand, the broader reach cameras are limited to roughly 30 meters by specification. However, longer cable lengths can be achieved if they are properly shielded and using high-quality copper wires inside. Additionally, the camera features an integrated ISP which links seamlessly with its 2.1 megapixel image sensor. The combination of these components makes it into an HDR-capable and very versatile little device. All the commonly used camera functionalities that you would expect, like mirroring, cropping, gamma correction, and auto exposure, are combined in a single heavy-duty package. The camera supports RTP and RTSP for video streaming, allowing you to seamlessly integrate it into the most common streaming applications. You can toggle between the H.264 and Motion JPEG codec, allowing you to adjust the camera to your specific application. When it comes to configuration, it supports the SUM-IP protocol, also known as ISO 17215, as well as our own Motec control protocol. The Motec control protocol allows you to change any parameter of the camera easily with a very simple to implement interface. The entire device family is IP69K rated and shock resistant up to 100G. This allows the camera to be used in even the harshest of environments in the agricultural, transport, construction, or stationary industries. We tested the camera to work reliably between -40 to 85 degrees Celsius ambient temperature, which should fit even the highest demanding in all your applications. The camera can be powered by a wide variety of interfaces, which we will learn more about in the slides to come. Let's dive right into the different versions available of the MCDx7000A camera series. A very common choice is the MCDe7000A. It uses a passive PoE injector that allows it to be installed easily into most applications. It requires an injector that puts power on the data lines along with the data itself, which the camera then separates and uses to run and stream. On the left side of the injector, however, only data comes out, which can then be safely connected to any M12 Ethernet switch or directly to your computer using an adapter cable available at Motec. The camera supports a power supply from 9 to 60 volts DC, which allows it to be used in a wide variety of applications, from normal automobiles to forklifts, which usually use a higher voltage onboard network. Next up is the MCDe7000A PoE. It is very similar to the PoE version, but instead of the injector, it can be powered directly by every PoE or PoE Plus compliant switch. In this camera, the data lines again function as power supply lines as well, allowing just a single cable to go to the camera to power it and stream video data. Please note that the PoE and passive PoE are not compatible with one another because passive PoE does not use the handshake which PoE switches use to detect whether a device needs power or not. Next up is the MCDb7000A, which, as mentioned before, uses the single pair Ethernet interface for communication. This camera can be connected to any SPE or base 100 T1 compliant switch. Because SPE, as the name suggests, only uses a single pair of twisted cable, the camera can easily be powered over the spare pair that the M12 provides without any additional wiring or hardware. This model still works with the same voltage range as our Ethernet-based cameras. However, to connect it to your computer, you might need a switch or a media converter that converts the base 100 T1 signal to a 100 or 1000 base TX Ethernet signal that the computer can understand. In this example, we used a SPE switch which also features a normal Ethernet output that additionally puts power on the spare pair to supply the camera. Last but not least, we have the MCDe7000A PT. PT stands for pigtail, and this device comes with an integrated 50 cm long cable that splits into an M12 decoded connector that can be connected to a switch or a cable extension, and a second connector of various sorts that can be hooked up to your local power supply, battery, or vehicle power interface. The reason why we feature such a wide variety of interfaces here at Motec is that different industries and applications favor certain interfaces or require a particular type of power supply. Let's take this forklift for example. The forklift has two cameras and a monitor that already features two Ethernet ports. So it is not necessary to add a switch to the system, which would increase the overall system costs and complexity. In this simple application, it is best to use two passive PoE injectors to power the cameras from the same power supply as the monitor and connect the cameras directly. Which interface to use can also be mandated by the industry you're working in. For example, base 100 T1 networks have recently established themselves on agricultural machines like tractors and implements. So using a T1 compliant camera is the most reasonable approach to stay compatible with the rest of your vehicle network. The single pair Ethernet interface is ideal for this application because it combines power supply and data into the same cable. This saves weight, cost, and complexity. However, in industries where the cables can get extremely long, like for example in the railway industry, base 100 T1 might no longer be sufficient to do the job. Additionally, these are longer, bigger vehicles that do many times feature a lot of cameras spread all around the machine. In this case, it is necessary to add a switch into the network because the monitor no longer provides a sufficient amount of interfaces for the cameras to connect to. With the switch already in the network, replacing it with a PoE switch does not contribute much to the overall costs of the switch. At the same time, adding a single PoE injector for each camera can increase the overall wiring requirements and also overall system costs. In this case, PoE is the most reasonable choice. Lastly, if we look at this example, we see one camera streaming directly to one monitor. However, the camera is on the trailer of a truck and the power supply shall not be provided from the truck all the way back to the camera, but rather by the trailer itself. For this, the pigtail camera can source the power locally, for example from your reverse light, so that the camera turns on whenever the vehicle moves backwards. Of course, all of these were just examples. Your industry might have specific requirements that I didn't consider in this video. So please feel free to contact us for more information and to find out which camera is the most suited for your application. With this, we've reached the end of today's video. I hope you found it helpful. If so, feel free to leave a comment or any question you might have right underneath this video.